All right, it's time for your favorite lesson, and that is applications. And in case anybody tries to convince you otherwise, applications is just a fancy way of saying word problems. So I'm sure you're thrilled about this. I will tell you right away that this work from your workbook isn't fantastic. Because this is the last lesson of this unit, rational functions, I think what is better than doing these kinds of questions is to go to any of the old tests that I've posted and take a look at those, because you have solutions to lead you through. Having said that, looking at these isn't a bad idea. Before we start this question, which is actually multiple questions, and I may need a second blank page for doing the work completely, I just want to go back to yesterday's note for a second, because these were the instructions for all the questions from the last note, so maybe not yesterday's. So this is the putting it all together note. So these are the criteria that we have been asked to find for every rational function. So word problems are going to ask you either to find the x-intercepts or some equivalent type of calculation, y-intercept or some equivalent type of calculation, vertical asymptotes, horizontal asymptote, oblique asymptote, maybe holes, but very doubtful in word problems, domain, and range. So you've only got 1, 2, 3, 4, 5, let's say 6, 7, technically 8 things, characteristics that you can find. So your job is to read a word problem question and ask yourself, which one is it fitting into best? So we're going to run through these, and I may flop back and forth between that note and this one, just to draw your attention to different things. I am going to assume that I'm going to need extra room, so I'm going to take this question and this question to the next page and move this one down so that we can talk about determining the average profit function, a p at x, and the formula for that is p at x over x. Now we're given functions that stand for estimated revenue, that's r at x is equal to negative 2x squared plus 8x, and a cost function, so a formula for cost, c at x is equal to 3x plus 2, and this is for the manufacture of a new product. So we're asked to find the average profit function. So the first thing we need to figure out is how to find profit. Now I'm hoping that you have a little bit of experience with profit, or understand profit even a tiny bit, because profit is actually revenue, how much you are bringing into your business, let's say. But profit is more than just, or I guess less than revenue, because you have to subtract off all your costs, and then you can figure out, have you made a profit or have you not made a profit? So for the purposes of this question, p at x, so the numerator of this function, is equal to r at x minus c at x. So I'm going to take all the little bits and pieces from this opening statement, and I'm going to create a formula for p at x. So r at x is negative 2x squared plus 8x, and then we minus c at x is 3x plus 2. And that is actually incorrect, because we're minusing all of this 3x plus 2, so you need to put brackets on that. And you will need to distribute that negative sign, or the negative 1, through the bracket. And then because this is grade 12 math, you need to collect like terms. So positive 8x minus 3x is positive 5x. And then the other two terms are the same. So this is the p at x function. This is the profit function. But we're not actually asked for the profit function. We're asked for the average profit function. So this is how much, this is a formula for how much you're bringing in when I tell you how many products you sell. But we want to know the average profit function. So what are you making per item? And that's what this is all about. Purple, let's go for it. So AP at X is equal to the profit function, which is this thing, over X, and that is the answer to this question. It's also finally a rational function, which is why it is under applications of rational functions. Until that point, there wasn't letter fractions, so that means that you didn't have a rational until right now. Now, I'm going to label that form number 1, as in this is one way you can write the formula. But this question, the next one, is to express this function in 2 different forms. So we need to make 2 different looking formulas for this purple version. So I'm going to go through a few steps. I think, if my memory serves me correctly, we have actually 3 more forms rather than 2 more forms. Just a piece of information that might be handy for you. I'm going to overdo it in this question. So step number 1 is realizing that that numerator is factorable. It's a trinomial. It's a complex trinomial. So the first thing I'm going to do is take out a negative. And I'm not going to count that as form number 2 because I'm pretty sure I can do better than that. I should be able to factor the trinomial. So I need 2 numbers that multiply to be 2. And 2 numbers that multiply to be 2. And cross, that's 4. Cross, that's 1. I need to be able to create the negative 5 that's in the center. And that is totally doable. And that's a positive 2, which is at the back. So I can actually factor this to this point. And this last blue statement is what I'm going to call form number 2. Now, let's look at another form. So this procedure actually reminds me a heck of a lot of finding x-intercepts, because we had to factor the top, or even wholes, even though we didn't get to that point because we factored first, and that was always our first step in putting together an entire picture. This could be form number 2, and this could be form number 3. I'm going to go looking for one more, and I don't know if you remember from the last note that I said that if you have a monomial denominator, you are allowed to, and I have a very unmathematical name for this, I call this uncommon denominatoring. So instead of putting everything over one denominator, I put each one under, or each one over the original denominator, and then I'm going to clean it up. So this kind of reminds me of horizontal asymptotes. So negative 2x squared divided by x is negative 2x, plus these x's cancel out. And we can't clean up this last term at all, so I leave it alone. And I'm going to label that form number 3. Now I will have to pop back here to answer part of this question, but the next question was to restrict the domain to represent the context, the domain of the function. So I'm just drawing your attention to the fact that this says domain, so that should trigger your mind to realize that it's domain. Now the hard part about this question is that it has to do with a word problem, so we have to represent it in the context of the word problem. So it's got to make sense for this word problem. Because hopefully you remember that domain is where you take the denominator, which in every single case of AP at x, the denominator is an x. So I have to take x and I say that it can't equal 0. And I went right to that because there is no solving, it's just done. Now, that actually makes sense. I mean, if you're a company and x is the number of items that you're making, you don't want to set up your company and then make no items whatsoever. But for the context of this problem, you should realize that if you're a company, you also can't even possibly make negative number of items. So we also have to make sure that x is bigger than 0. So being 0 is bad, being negative is bad, so you can say this. This is one of the possible therefore statements for restricting the domain of the function to represent the context, because x is the number of items being produced. Another way to write this, just to remind you of its existence, is that we want a number of items all the way from 0 to infinity. We don't want to include 0 items because that is bad business, and you never include infinity. So that's another way to write it. And the last question for this is, what are the break-even quantities? So this requires you to know something a little bit businessy. And break-even, in case you didn't already know this, means that you are making 0 amount of money and you are losing 0 amount of money. So that's a fancy way of saying your profit, or your AP at x, is equal to 0. And I think I said this wrong. You're making, yes, you're making no money and you're losing no money, so that means your profit is 0. Sorry, I've had a bad evening. I set this up for you already. This is me. I got home from school today and found out that I had a flat tire, and then decided to do a little bit of paddleboarding, and I had this cool experience of being under a goose takeoff from Little Lake, only I also had the experience of having a goose poop on me. So I'm a little rattled. Back to the question. So I'm going to take AP at x and I'm going to equal it to 0. Now that should remind you of x-intercepts where you let y equal to 0. The problem is you have 3 forms to decide from. Do you want to let the purple form equal 0? Do you want to let the red form equal 0? Do you want to let the blue form equal 0? And the quickest answer, but not the only right answer, is this blue one is the best one. So I am going to take this, and because I have magic smartboard abilities, I'm going to take this, I'm going to group it together, I'm going to clone it, and shove it onto the next page so I don't have to depend on my very, very poor memory to move it over. So now that I've got that, I can let that equal 0. Which means 0 over 1. Nice line. Then I can do my cross multiplying. So 1 times anything is itself. And 0 times the denominator is 0. So you have -1 at the front equals 0, which you don't even have to write down because that's not a possibility. 2x minus 1 is equal to 0, and x minus 2 is equal to 0. Remember that this is optional. It's to almost guarantee that I'm not making any silly mistakes in public. So this one has a little bit of work, and I can then say that x is equal to 1/2, or x is equal to 2. Now you might be saying to yourself, okay, wait a second, you told me that x is the number of items being produced. You can't make half an item, and that is true. But every once in a while you will get a question that states that, for example, x is the number of items in the thousands. And then this isn't actually a half. This would represent half of 1,000, in which case you're talking about 500 items. And this wouldn't represent 2, it would represent 2,000. Having said that, I'm just going to give you a therefore statement using these numbers because that language isn't in there. So to break even, to make no money, and to lose no money, the company would need half an item or 2 items. All right, I'm going to take a little break while I set up for the next question. It may take me a little bit because it is 9:04, and because of my horrendous day, I haven't actually eaten dinner yet. I have no idea what that is. So good time to pause. All right, question number 2. This one, some of you might feel like this is a bit of a stretch, but it is doable because you are in grade 12. That means you have all the skills to do this question, whether you realize it or not, or whether you feel comfortable with it or not, but have faith in you. So the concentration of a toxic chemical in a spring-fed lake is given by the equation C at x equals 50x over x squared plus 3x plus 6. Where C is given in grams per liter and x is the time in days. Determine when the concentration of the chemical is 6.16 grams per liter. So, something I like to do with word problems, especially when they're unfamiliar, like I haven't taken chemistry since high school, honestly. So, what I like to do is I like to make a little note off to the side for myself. So I have a C to worry about in this question, and I have an X, and we should have values for those. So, for instance, C is given in grams per liter. So I can write that down and not have to struggle with my therefore statement at the end. And X is the time in days, so I'm just going to scribble down days. So what we have to do is we have to figure out what to do with this thing. And that thing is grams per liter, so that is a C, or more specifically, C at x. So I can take 6.16 and put it in for C at x, and I can equal it to the formula. Now this is the same sort of steps as you would do with x-intercepts. The thing, or the beauty about x-intercepts, is that instead of having 6.16 on the left, you have 0, and 0 gets rid of a whole heap of stuff. Unfortunately, 6.16 doesn't get rid of a whole heap of stuff. Regardless, you need to put the 1 on the bottom, and you need to multiply. So I am going to multiply in this direction first, which is normal for us as far as this goes. So 1 times 50x is 50x equals, and then the other direction, is 6.16 times x squared plus 3x plus 6. So normally that would be 0 because the top would be a 0. The thing is, this is going to have to mean that I multiply out the 6.16, or multiply it into the bracket. So that's 18.48x plus, beyond my capabilities, 6.16 times the 6 at the back is equal to 36.96. Now, this is a quadratic. We've lost the fraction, which is awesome news. But because it's a quadratic, you can't do anything useful unless you have a 0 on the other side. So I'm going to bring that 50x over from the other side and collect like terms. So I'm going to show that in 2 steps. If you feel like it, you could do it in 1. It's up to you. And there's something I also can't do in my head, or I'm not comfortable doing it in my head and finding out that it's wrong at the very end. So I know this is a negative and it's going to have an x, and then I have plus 36.96. So $18.48 subtract 50 is equal to negative 31.52x. All right, so there's my quadratic. Pretty darn ugly. Not something I even want to think about factoring. So I am about to use the quadratic formula. I say that like I'm happy, but really I'm sad that this isn't worth trying to factor. You can try it if you like. I'm pretty sure it doesn't. I'm going to use A is 6.16, B negative 31.52, C is equal to 36.96, and because I'm going to be going back and forth between my calculator, I'm going to take a little break and do that while you're not witnessing this. I will come back and explain my work. Okay, so I think that's a safe place for me to come back. So I took B is negative 31.52, and because it's negative B, that's a positive, plus minus B squared, so it's a negative, so it has to sit in a bracket, minus 4, there's A, there's C, all of it over 2, there's A. Then 31.52, I left it the same, plus minus, I calculated all the stuff under the square root sign, and then I also calculated the denominator. So now I'm going to dig out my black pen again and actually show you, or I guess remind you, how to put this into your calculator. It means that I'm going to have to shift this guy over a little bit. Let's see if I did that right. Oh, I knew it. Okay. All right, I think I can do this by memory. So the first digit was 31.52 positive, and then I add 82.816, but I have to square root it, equals to find that overall top answer, and then I divide by the denominator, which is 12.32, and I get an overall answer that is huge. I'm going to choose to round to 2 decimal places, so I'm going to write 3.30. Then I'm going to do the whole thing over again. I was right with that 31.52. I'm going to do that whole thing over again. I'm going to do the minus version. So 31.52 minus 82.816 square rooted equals, to finish off the top, divided by 12.32 equals, to finish it off. And again, I'm choosing to do 2 decimal places, so that's 1.82. And I don't have to look very far to find out that because those are x's, I'm dealing with days. So basically, if I remind you what this question is all about, it's about when the concentration of the chemical is 6.16 in this spring-fed lake. So I can write, therefore, it will happen, kind of a little bit of a budget therefore statement, at 1.82 days and 3.30 days. Now, from past experience, most students who are taking advanced functions are taking it because they need it for some business, economics, marketing type courses in university or college, or they're taking it because they need to go into the sciences, which requires a lot of math. So what I tend to do when I'm teaching advanced functions is to make sure that I put in an effort to cover money questions and also science-like questions, whether it's chemistry, biology, physics, those kinds of things. There isn't a lot of overlap between those topics. The other reason you might be taking advanced functions is because you just love math. So if that is your reason, all of this shouldn't bother you, or the 2 concentration places, the money and the science, shouldn't bother you at all. We have one last question. I'm going to set it up in a second, but this one is also about money. I'm going to read this first part for you before I start moving this stuff a little bit off. The function I at t is equal to 15t plus 25 all over t, and it gives the value of an investment in thousands of dollars. There's that thing I was mentioning. So when you spit out the investment, it's going to be dollars, but you have to worry about the fact that it's in thousands of dollars. So if you get an answer of 5, it's not $5, it's $5,000. And t is the number of years. So the first question is, what is the value of the investment after 2 years? The second question is, what is the value of the investment after 1 year? C is, what is the value of the investment after 6 months? So you should be able to do these quite quickly. I'm going to give myself a little bit of room before I break it to you which of these it is leaning towards. So not necessarily exactly, but leaning towards. So give me a sec to set this up, and I'll be back. Okay, time's up. I'm back. Tiny break. So what is the value of the investment after 2 years? I've given you a 2. I've given you a 2 years. That means the 2 slides in for the t here, which means you also slide it in for the t in those 2 places. So I'm going to do that right now, and I'm going to pick, I don't know, black again. So I at 2 years is equal to 15 times 2 plus 25 over 2. So I'm going to show a bit of work. 30 plus 25 over 2, which is 55 over 2. And 55 divided by 2 is, bad day, 55 divided by 2 is 27.5. That does not mean we have $27.50. That means it is worth $27.5 $40,000. So that looks like this. So you would have to take that and times it by 1,000. This should remind you, loosely maybe, of finding the y-intercept. And the reason I say that is the y-intercept was where you took 0 and subbed it into the original equation. All I've done in this question is I've not taken 0 to sub it into the original equation, but I'm asking you to do 2 into the original equation. Next question is exactly the same thing, only this time you're subbing 1 into the original equation. So my original equation, 15t plus 25 over t so I at 1 is equal to 15 times 1 plus 25 over 1. And I'm too lazy to continually put the 1, so that's 15 plus 25 over 1. So that's 40. And again, not $40. $40,000. Now, why would I have the same question again but give you a different number? The reason is because I want you to be aware of what you're doing. And if you are going on in math, you are going to have to be more and more aware. What I need you to not do is this. And the reason is because way up here in blue, I said that t is years. And if you put 6 in where the t is, that means you're talking about 6 years as opposed to 6 months. So 6 months is really half a year. So I need to correct this mistake. So 15 times a half plus 25 over a half. So half of 15 is 7.5 plus 25 divided by a half. Um, 25 plus 7.5 is 32.5 divided by a half. Now, that's not good enough, so we actually have to finish this off. But I want you to realize that when you're dividing by a decimal, you're going to end up with a bigger number. So 32.5 divided by 0.5 isn't half of 32.5, so it doesn't make it smaller. You actually are going to get, let's see, just to be on the safe side, 32.5 divided by 0.5, 65. So that means at the half-year mark, it is not worth $65, it's worth $65,000. So if I put this on big screen for a second, hopefully you can see a little bit. Ooh, that's terrible. Decent. So this is 2 years, and it was worth, actually, let's start here. This is half a year, and it's worth $65,000. This is 1 year, and it's $40,000. This is 2 years, it's $27,500. So even though as I asked the questions, the numbers went up for the amount it's worth, if you think about it, I asked it in the opposite order. This is the least amount of time, this is the most amount of time. So this investment is actually quite terrible. It's gone from whatever it started at to $65,000 to $40,000 to $27,500. This is not a good investment. What I'm going to do is pause for a sec, put this back so you can actually see it, cut and paste this so you know what I'm doing, and come back and we'll answer D, which is not a typical test question, but I will cover how to answer questions like this in case you ever see them in your future. So I hate to break this to you, but there's no actual answer to this question, not like the last question, which was $65,000. This is a thinking question, the kind of question that most students really don't like. What matters is that you give an answer and then you give a reason, because that's what it's expecting. You give a reason and your reason is plausible. That's how you get the marks on a question like this, whether it's in this class, where I tend to not have questions like this, or somebody else's class, if you're taking math with somebody else, either in high school or university or college or trade school or wherever you end up taking math again. So let's read this question. It says, there is an asymptote on the graph of the function at t equals 0. I have not told you what kind of asymptote it is. So you actually have three choices. You have a choice between vertical asymptotes or horizontal asymptotes or oblique asymptotes. And given this information and the equation, you should be able to figure out what kind of asymptote it is. And the answer to it, in case it's not obvious to you, is this is giving you a vertical asymptote. And the reason I say that is because when you're asked to find a vertical asymptote, you let the denominator equal 0, which in this case is t equals 0. So that's why it's a vertical asymptote. So I'm just going to shove that in here for a second. So there is a vertical asymptote, and it's sitting on the graph at the function t equals 0. So if I draw a little doodle, and I'm keeping it to quadrant 1 because quadrant 1 is where time will be positive and the investment will be positive. There is your asymptote. So the question is, does it make sense that there is an asymptote there? Explain why or why not. So there's a couple of popular answers for this kind of question. Number one answer, and this is the one I'm going to leave you with because it is the one that I agree with the most. That does not mean that it's the only one you get answers for. It's the one I agree with the most. And I would say, no, it doesn't make any sense at all. Because if this function is getting less and less and less and less as time goes on, that means that you would be getting closer and closer and closer to this asymptote. And if you're getting closer and closer and closer and never touching the vertical asymptote, which is not a thing, then you never know what you started the investment with. So I'm going to take out my therefore statement and put in a because. No, because you would then never know the starting value in dollars of the investment. Now a case could be made for yes. I'm not going to go there, and the reason I'm not going to go there is because I don't actually fully think that that's the right answer. But if you could back it up and convince me, I would have to give you the marks, because you would then have answered, does this make sense? And you would have answered the explain why or why not. So you would have covered that. Now, in a test situation, because we've only had one to this point, in a test situation, if I don't understand what you're trying to say, I'm going to put a little mark or note on your test to say, hey, can you come talk to me? Because I want to give you all the marks that you are supposed to get credit for. So please know that you may get a mark that's on the top of your test with a little notation that will give you a chance to explain it to me and then increase your mark. So I wouldn't leave you hanging except if you just didn't want to talk to me. And I'm hoping that never is the case. Anyways, that is rational applications. So again, everything applies to this list. And also, again, from the beginning, I don't believe that this list from your booklet is fantastic, and I really think that the more appropriate indicators of what I will ask for on a test are available on the old tests. So that's your best place to go. Anyways, good night. I will leave you with that. I really hope the stain comes out because I really do like this t-shirt. Anyways, take care. Bye-bye.